Welcome, my students. We are talking about lesson 33 today, and let's start with products of prime factors. So there are two types of numbers in regards to factorization. We have what's called a prime number, and a prime number means that the only factors are one in itself. So 1 times whatever the number is, right? The other type of number is a composite, and a composite can have more factors than one in itself. So more factors than 1 times n. So let me give you an example of a prime number. 2. The only thing you can multiply to get 2 is 1 times 2. 3. The only factors you can multiply are 1 times 3. 5. The only factors you can multiply are 1 times 5. Okay? Those are prime numbers. Let me move this. So those are prime. And these are composite. So composite numbers are like 4, where yes, you could say 1 times 4, but you could also say 2 times 2. Or maybe you have 20, where you have 1 times 20, but you also have 2 times 10, and you also have 4 times 5. But you could also have 2 times 2 times 5. And if you notice, each of these numbers are prime numbers. This is prime factorization. Prime factorization is where you look at the factors of a number and you break each factor down until it's a prime number. So you factor it, you factor it, you factor it until everything that it takes to come up with this number when you multiply them together is prime. So let's look at an example for that. Let's look at example 33.1. Let me see if I can just move the page around. Yeah, let's look at example 33.1 on this page. Let me get it a little bit bigger. There we go. 33.1. We are going to express 80 as a product. And product means to multiply of prime factors. So express 80 as a product of prime factors. So that means whatever it takes to multiply, whatever prime numbers it takes to multiply to get 80. So the way that I do this, and the way that I recommend until you get the hang of it, is to use a factor tree. And a factor tree is simply, it's kind of like a family tree. You have the little branches. And you could also, I like to do it like this too. So we have 2 times 40. And I start with the smallest prime number that I can. And those prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23. These are all prime numbers. You can only get them by multiplying them times 1 in themselves. So it's handy to have a little list of these in your notebook. you can just write it in the back cover near the margin, so, or near the edge, so you, just a place where you know you can go and look, so you don't have to try to think of them every single time you need to reference prime numbers, right? And then over time, you can add to the list so that you can see the bigger prime numbers that are out there. And then when you have a question on a test that says give me the sum of the prime numbers between this number and this number, which are some things that we've definitely had before, it's a lot easier, right, to calculate that if you already have a list of those prime numbers. So anyway, back to 80. I started with the smallest prime number that I knew would go into 80. So 2 times 40. So now I'm going to factor 40. And I know that 40 can be factored as 2 times 20. So now I'm going to factor 20. 2 times 10. And I know 10 can be factored, so let's factor 10 as 2 times 5. That's it. 5 is a prime number. So I have taken 80 all the way down to all the primes. So the thing to do now is to count how many factors are alike. 80 equals 1, 2, 3, 4. So 2 to the 4th. And we just have 1 5. So it's just 5 by itself. Okay, do you see what we did? This equals 2 times 2 times 2 times 2 times 5. But we just used our exponent rule of having that little 1 right there. And we added our exponents together. It's the same thing as this right here. 2 to the 4th times 5. All right, and this would be the answer that I want to see in your homework. I want to see the exponents when you have factors that are the same. I don't want to see this over here. This is pre-algebra work. You are in Algebra 1. Give me this, okay? You guys can do it. You are more than capable. You are smart, intelligent young women, and you can do this. I have no doubt. All right, so let's look at another. I'm going to just erase this so that I don't have to rewrite all of this other stuff again. And I'm going to change the number. And this time we're going to express 147, and this is example 33.2. So let's take 147. Okay, so we know we can't use 2 because 2 is for even numbers. If you have an even number, start with 2. So let's try 3. So let's make our little tree, and let's put 3 on this side. And you could even go 147. Go ahead and get it started, equals. And let's bring up our calculator. Let's try 147 divided by 3 equals 49. So we can put 49 here. Now, if you remember your multiplication tables, we know that 49 is 7 times 7. From our list, 7 is a prime number. So this is as far as we can go with 147. And we have 7 once, 7 twice, so 3 times 7 squared. And it's, in general, whenever you are writing out your prime factorization, you want to put the factors in numerical order from least to greatest. So you would not say 7 squared times 3 when you type it in. It'll get marked wrong. Even though it's right, it'll get marked wrong, because the generally accepted rule for mathematics in prime factorization is that you put the factors in numerical order from least to greatest. So you would write it like this, and this would be the answer that I would want to see for prime factorization for typing in your homework. 3 times 7 squared. All right, that is so easy. You guys can do this. I have no doubt. But you see how handy it is when you have your list of prime numbers and you get down to this point, you say, oh yeah, that's a prime number. You don't have to think about it. You don't have to go any further. So put this list on your back cover and refer to it whenever you're doing prime factorization. It'll be a handy helper. All right, so let's clear this page. And we're going to go back up to our other page, which is the one I prefer. And remember these terms, prime and composite. Composite means it has more factors than just 1 times itself. Prime means that it only has factors of 1 times itself. That's going to help you a lot when you go to solve problems. Let's clear the page and let's talk about statements about unequal quantities. And this is tying back into your algebraic phrases where you're given a word problem, but it's a little tricky on the uptake. So 33.3, we already did 33.1. 33.3 says this twice a number is 42 less than negative 102. All right, so we know what twice a number is. Twice a number is 2 times a number, right? So we got that part. Is our equal sign. We know that too. Now we have 42 less than negative 102. How do we handle that? Because it's like 42 less than comes after the other. Do we have to do it like that? You can if you want, but here's what I do. I take 42 less than. That means you're going to be taking 42 away. So that's subtraction. 42 less than is this number minus this number. So you can go ahead and write minus 42 because you're going to be subtracting 42 from whatever the second number is. And in this case, it's a negative 102. And it doesn't matter whether this other number is negative or positive. The negative sign on this number here makes this a subtraction. Okay? So do not worry about that. Worry about this. Now, you're going to see some more that say, it might say 42 more than, or 42 greater than. That means addition. 42 less than, or you could also say is decreased by 42. That would be the same thing. Twice a number is decreased by 42. That's a minus 42. It's the same thing. It's just a fancy way to say 42 less than or subtract 42. All right, so these two are the same type of phrase. All you have to do now is solve the problem because now we know how to set it up. The other way you can set this up is to say, okay, twice a number is 42 less than. So it's going to be minus 42. It's going to be something minus 42. So you can leave a little gap in here, and then you put whatever it's subtracted from in front. It's the same problem. It's the same problem. So it's up to you as to which one makes sense in your brain. Does it make sense to you to subtract it on the end or to put a negative 42 in the beginning? It's the same thing, right? Right. So let's solve. Just think about it and you'll understand what I'm talking about. So 2n equals negative 144 because these two added together are negative 144. We divide both sides by 2 because we want n by itself. Sorry, I haven't had breakfast. My tummy's growling. Negative 144 divided by 2 is negative 72. And that is the right answer. Yay. All right, let's look at 33.4. We have another example that we can work through to see some more of these word phrases or algebraic phrases that might trip us up. So this says 5 times a number is 72 greater than the opposite of the number. All right, 5 times a number. So it's 5 times, my pen is all goofy, 5 times n. All right, 5 times a number. So we did that part. That's the equal sign. 72 greater than. 72 greater than means plus 72, right? We're adding 72 to whatever that number is. Now we have the opposite of a number. So the opposite of a number is when we take that -1 and multiply it times the number. So minus n. So 5n equals 72 minus n. So we just need to change the side. We need to swim our little fish over here. So we're going to add, and this is always an invisible 1 right here, we're going to add 1n to both sides. So it's going to be 6n here. It's going to cancel over here. 6n equals 72. We divide both sides by 6. And n is equal to 12. Voila. That is our answer. All right. Moving on, we have another one. I'm just going to kind of run through most of these phrases so you know what they are. All right, I'm going to write this one out and then let you solve it. All right, my students, here is the problem. If the sum of twice a number and -14 is multiplied by 2, the result is 12 greater than the opposite of the number. So I want you to pause the video and solve that for me, and then you can press play and see if you got the same thing I got. Okay? All right, so go ahead and pause. All right, let's start with the problem itself. If the sum, so we know we could do some parentheses here. That usually is an indicator. If the sum of, right there, that means parentheses. Twice a number, that's here, 2n, and -14. So 2n and -14, the sum of 2n and -14, in parentheses right there, is multiplied by 2. So we put our 2 in front, right? So it's 2 times the sum of twice a number and -14. The result is, and that's our equal sign right here, 12 greater than. So I just put in a positive 12. 12 greater than. The opposite of a number. The opposite of a number we know is a negative. So -n is always going to be the opposite of the number, right? Anytime you see the opposite of the number, it's -n. Okay? So now we have our problem. Now all we have to do is solve it. So check first and make sure that's the equation you got. If that is not the equation you got, see where you made a mistake in understanding the language to the equation. Go back and look at that. Fix that and then solve it. And I'm going to give you the opportunity to do that. So go ahead and pause, fix your equation, and then solve it if you need to. If you got the equation right, then you don't have to pause. You can just keep watching. All right, so now we have the 2 times the sum of, so we need to distribute. So that's going to be 4n minus 28 equals 12 minus n. Now, we want to get the n's on the same side. This n is bigger. So let's move the smaller one over. So we're going to add an n to both sides. And we're going to take this and move it over here. So we're going to add this to both sides. So these cancel and these cancel. Now we have 4, and this is always an invisible 1. So 4 plus 1 is 5, n equals, and this is going to be 40. So when we divide both sides by 5, we get that n is equal to 8. Okay? So if you did not get n is equal to 8, I suggest you pause, go look at the problem, see where you made a misstep, and correct that in your example. We have one more. We can do that one together. 33.6. And let me go ahead and write that for you. All right, so here is the problem. 5 times a number is 21 less than twice the opposite of the number. What is the number? So let's start with 5 times a number right there. 5 times a number is equals 21 less than, so minus 21, twice, so we're going to have something else here, so plus is just and, it's less than, twice, and the opposite of a number is always negative n, so twice negative n, right? So it's 21 less than twice negative n. So now we just need to distribute. 5n is equal to negative 21, and this is going to be 2 times negative n, so it's going to be minus 2n. All right, let's add to both sides. This becomes 7n equals negative 21. When we divide both sides by 7, n is equal to negative 3. Okay? So that one was pretty straightforward. This can kind of throw you for a loop when it says twice the opposite, or 4 times the opposite, or 3 times the opposite. You can write it as a multiplication. Put twice the opposite, or if you can already do that in your head, then just minus 2n. Okay, it's the same thing. We see that once we move to the second step. So it's all about, do you need to write it down like this for clarity, or can you skip that step and go straight here? That's up to you. But in this case, the answer is negative 3. And we solved that correctly according to the book. All right, so you have some practice problems, and I trust you will do well, and I'll see you in lesson 34.